Welcome to our lecture on analyzing flight delays with hypothesis testing. I'm the programming professor, and today we'll dive into how data from New York City airports can be used to understand delays better. Today, we'll discuss selecting the right hypothesis tests for comparing delays at various airports. Practical applications using Python for data comparison. How to interpret statistical outputs like test statistics and p-values. And finally, we'll look at what it means to have a difference that's statistically or practically significant. Let's start with our case study on flight delays. This is an important topic because delays can severely impact both travelers and airport operations. We're looking at data from three major NYC airports, Newark, JFK, and LaGuardia, focusing on flight destinations, scheduled departures, flight durations, and delay statuses. Our first aim is to compare the proportion of delayed flights between JFK and LaGuardia. The null hypothesis here states that the proportions of delays at these airports are the same, while the alternative suggests they're different. We use a two-sample proportion z-test to check this. Here, we see Python in action for this proportion test. The code imports the necessary function from stats models, sets up our example counts and observations, and then performs the z-test to give us a z-statistic and a p-value, which we interpret to see if there's a significant difference in delays. Interpreting these results. The z-statistic tells us how far our data is from what we'd expect if the null hypothesis were true. A p-value less than 0.05 would lead us to reject that hypothesis, suggesting significant differences in delays between the two airports. Next, we shift to comparing the mean delay times. Here, our hypotheses are similar but focused on the mean delay times. If variances are unknown or unequal, we use a t-test for independent samples to compare these means. Again, Python demonstrates its utility. This code snippet runs a t-test on simulated delay data for JFK and LGA, providing us with a t-statistic and p-value to assess if there's a significant difference in average delay times. Now, let's talk about significance. A statistically significant result from our tests shows there's a difference, but we must also consider practical significance. For instance, a 1-minute difference in delay might not matter much in practice, but a 30-minute difference certainly would. In summary, we've explored various methods to compare flight delays, used Python to perform these analyses, and understood the implications of our findings in both statistical and practical terms. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.